Okay. So one more time on that. Relative maximums, any peak or valley, the points on either side relative to it are lower. So what's that make a relative minimum? Yeah. It is lower than the points on either side of it. So any valley you see I had a nice time drawing this graph, yes. Okay, so there's relative maximums, relative minimums, but then there are also absolute maximum and absolute minimum. Okay, what's the difference when you put the word absolute on the front? The highest point on the whole graph.
No. The highest point graphed on the graph, you stupid dumb.
Caleb, that is inappropriate.
Well, it's not my fault. He's stupid.
Yeah, but you don't call people that.
When your little cousin.
You realize you have a lawsuit being recorded.
He can sue me. I'm not 18, so he can't sue me, actually.
Okay. Highest point on the graph, lowest point on the graph. Does every graph have to have an absolute maximum and an absolute minimum?
No.
I got a no, I got a yes.
No. What happens when
Does this graph have an absolute maximum?
No.
Yeah.
What is the highest point on this graph?
We don't know because it's still going.
Yes, it's going up forever. There is no highest point. We can't reach a highest point. So this one actually does not have an absolute maximum. Okay, so tell me, on this one, what are the relative minimums?
Let's see.
-6.
Okay, and they are going to ask you to list these as coordinates. So what are the actual coordinates of the relative minimum?
Did we do this last year or something?
Yes, we did.
Yeah.
Yes, it is. Okay. What be?
7, 6. 7, 6. Second, I don't know.
If we're shooting for this one, how many over? How many?
7, -6.
So 7, -6. You're over 7, down 6. That's a minimum. What else? -1, -2. 1 left, 2 down. That's a minimum. Okay, those are our only minimums. What about relative maximums?
-4 up 6.
Yeah, so -4, 6 would be a maximum. It is a high point on the graph. Relative. It's actually 2, 1. Okay. Here's the origin. You're only 1 up. Okay, so 2, 1 is your relative maximum. Now, they're actually going to ask you then, what's the absolute minimum? What is the absolute lowest point on the whole graph? And once again, because I made this one go down forever, never, never. Okay, in mathematics, if it stops, then I have to put a point on it to say stop. Otherwise, it's assumed that the graph is just going to continue forever. So, is that a point? You can't count infinity, because whatever point you name me as infinity, I'll name you something one more. So you would say there is none. And what would you say for your absolute maximum?
No, absolute.
There is. It's going up forever, so there. In this case, there's none.
If the graph continues.
Yeah.
There's no point. It's continuing.
In order to make it stop, I have to put a point on it indicating it stops. Otherwise, you assume it goes forever.
I'm proving my point to Super Devin.
Okay. Now, so is it possible for any graph to have an absolute maximum and an absolute minimum?
You have to have one.
Because, like, suppose I had made this one. If I had taken this one, what if it had turned around? I want to put a different color on here. What if this one had turned around and gone back upward? I would have an absolute minimum now at 7, -6, but would I have an absolute maximum? No. Nope. So how do I get both an absolute maximum and minimum on one graph? Oh, okay. Oh, okay. So Michaela, are you trying to say do this? You were doing this with your finger. That's what I'm trying to. Oh, okay. Oh, okay. Anybody think of a way I can get it both an absolute point? I can make that an endpoint, yes, if I stop it dead.
Or make it go completely vertical.
Yeah, if I had an asymptote out here and I made it go level, follow the asymptote.
Yeah.
And if I had made this edge have an asymptote and level off, then yes, I would have an absolute maximum at -4, 6 and an absolute minimum at 7,
What about that if you did this thingy?
Okay. If I did, depends on how I did it. If I did it so that it exactly balanced the whole way, they're all exactly the same height, you would have you actually would have an infinite number of absolute maximums and an infinite number of
But
absolute
what if they were all smaller than the one up there and the one down there?
Oh, then I could say that's the maximum and the minimum. Yeah, if I had looked.
It would go off the graph, and we would just assume it doesn't go up a bit.
Yeah, you would assume that it continues in that little wavy thing, and then yes, you could still have a maximum and a minimum about this.
What do you call that? Is that?
Well, actually, I could make that do that with a trig function. The graphs of sine and cosine are waves.
Oh, yeah, okay.
And you can make it, with some changes in the equation, you can make it do a bigger hump in the middle and then level out. Okay, so, on your assignment sheet, on this section, oh, by the way, I need to explain this. Okay, you're on the third box down. You're doing this box, and you'll notice this arrow curves up. You're doing these problems up here in the big box today. Yeah. Okay, this that I just did right now, that is section 1.3. Once again, follow my instructions there. Do not do whatever the book says. Don't do what the book says. When I said identify increasing and decreasing intervals, which we still have to talk about, relative and absolute maximums and minimums, that's all I want you to do on those problems. Do not do whatever the book says. Do what I say. Okay?
Okay.
Same way, in a moment when we get to section 2.1, the book is going to say graph them. I'm telling you, you don't have to graph them. You just actually we're going to remember how to find the vertex in the problem. That's all. But I do need to talk increasing and decreasing here, and I ran myself out of space. Okay. We also did talk about this last year, but I don't know if you remember it.
You didn't teach us anything.
Okay. You can also have what are called increasing intervals and decreasing intervals. By my putting the word gentleman in the corner, if the three of you want to come do this,
Cody wants to show you how to do this.
by saying I want you to name me an interval, how does one write an interval? You just did interval notation last chapter. How do you write an interval?
Yeah, Blake. Come on, Blake.
Yeah, it's the brackets and parentheses. You say you're going from -7 to 4. That means we're starting at -7, we're going to 4. Okay. On here, where we also want to know when our graph's going up and when our graph's coming down. When a graph is rising, we say it's increasing. When a graph is falling, we call it decreasing. Okay. So, I actually am going to turn this back to the original graph. Okay. And put it back to the original graph. Okay, so, using x coordinates, this is only done with x coordinates. We probably should note that. Use x. Yes. Where the graph goes up, where the graph comes down. That's it. Okay, so work left to right. What is this graph doing right now? As I work left to right, is the graph increasing or is the graph, it's going up? Okay, it's going upward until I get to -4. How do I do, in interval notation, how do I write the interval on the x-axis from here to here? Yes. -infinity to -4. Okay, when they write intervals like this, they'll just always use parentheses because that topmost point is in both the increasing and decreasing. We just always write intervals like this with parentheses. Okay, so then, as you move across this graph, what does it do after -4? It starts to decrease until I get to what x coordinate? -1. It's going downward between that interval from -4 to -1. So we would say, oh, my decreasing interval is -4 to -1. This is not a difficult thing. So now you are here. What is the graph doing? It's going up again. It's increasing until I reach what x coordinate? 2. So I reach 2. So I would say that one is from, I'm increasing from -1 to 2. No, they just list them as separate intervals. It's not a solution. It's not like you solved the problem.
Yeah, Tim.
Okay, so now you're at 2. What's it doing? So from 2, we're going down. So look at your you're only doing x-axis. From 2 to 7, I am decreasing.
Why are they all
Because the endpoints are in both. I could say this point is decreasing, or I could say this point is increasing.
Okay, so
They just don't use those endpoints when they list intervals.
okay.
I don't really have a great reason for you there, but. Okay, and then last but not least, I'm at 7. I'm going upward forever, but my x coordinates are going from 7 to where? 7 to infinity. That is a really easy concept, but I always have people start trying to tell me the y coordinates, how high or low it is. It's just dividing the x-axis into sections.
Yeah.
So we had an increasing section, then we had a decreasing section, then we had an increasing again. It's all based on the x-axis, and I can't get people to stop using y coordinates. It's not hard. So we just, whoops, that was supposed to be red. It didn't go. So you should have section, 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 section. You're sectioning off the x-axis. Only the x-axis. You're about to say to bed that. Can't get that to stick.
Well, if you say increasing, decreasing, you mean.
Yeah, so people start doing the peaks and valley points. That's not what you use. It's dividing the x-axis into sections.
Not what you do.
All right. Second thing we need to do today. I told you, this is 3 totally different things here. So, second part, you're going to wow and amaze me and tell me you learned this last year. No, we'll be back to it on the very last thing. Yeah.
Hey, we learned this last year.
We did learn this last year. Okay. Not
Hey,
much.
you got about a minute.
Okay, I can do this in a minute. If you all be quiet, let me. All right.
Cody.
If I give it you a parabola in that form, where's the vertex? Because it's going to go left 4, up 7. So the vertex is at -4, 7. No big deal. We can do that in our sleep. But where is the vertex? If I give you one, probably would be better if I gave you one. I don't know if you noticed that was worked out. Okay, we're going to probably get bad numbers here because I'm inventing this. If I give you 3x squared minus 15x plus 4, and I say, where's the vertex on that one? How do you do it when it's in standard form?
I give up.
Okay. There's two ways to do this. You are really close. You can, for those of you who are new to us, you might have done it by completing the square, which takes several steps. I teach it. You can get the x-coordinate by remembering a little simple formula. You guys were close back there. They said A over B. That's not quite right. It's negative B something else. 2A. Negative B over 2A. Now, how do you know which numbers are A and B? Yes, it's the same as in quadratic formula. A is the first one, B is the second one, C is the third one. So in this case, if I did negative B over 2A, I would do, what's negative B here? It would be positive 15 over 2 times 3, which is 6, and C, this is bad. I'm going to get 15 6, which reduces down to 5 halves, or in this one you can do 2.5 since it divides evenly. You want 5 halves or 2.5? So I can live with a decimal if it's exact. Okay, you know the x-coordinate of the vertex. How can you get the y? Yeah. To get the y-coordinate in, rub in.
Hey, why are you putting 2, 5, like 2.5?
5 halves is 2.5. 5 divided by 2 is 2.5.
Oh, okay. I think it's good.
Okay. So if you want, then when you want the y-coordinate, you literally just have to take your equation and go, what's 3 times 2.5 squared minus 15 times 2.5 plus 4. You get out your handy-dandy calculator and you crunch a number.
Please don't tell me we're doing systems of equations.
Not now, next chapter. Well, we're going to use them for something. I'm not going to reteach you the same stuff. We're going to use them. Okay, I have a negative 14.75. We're going to believe her. So when you write me the coordinates of the vertex, you're going to write me 2.5, negative 14.75, and there's the vertex. Okay, realize,
18 minutes.
thank you. Realize at that point, if I say graph this horrible, icky thing, you would plot that vertex, and then you graph it like normal. If I said plot it, then you'd go back to your 1, 2, 3, 1, 4, 9. From this vertex, you would just plot it like usual. It has a 3 in front, so you would have to alter all these coordinates by timesing them by 3. But it's normal graphing on the problem after that. All this does is find you the vertex, and you can plot the rest of it at exactly the same, no changes. Okay? That is the second section. Woo! No, let me stop it. Sorry.